Hello everyone and welcome to another problem solving session, Special Maths Academy. And in today's video, we are going to cover another problem from the Junior Second Round Maths Olympiad 2021, fifth problem in the exam. So it goes like this. Three real numbers satisfy the following properties. The first property being that the square of their sum is the sum of their squares, and second one being the product of the first two numbers equals to the square of the third number. So find the numbers. So go through the question together. And because of this last property here, that is specified explicitly, the first two numbers and third number, we're going to explicitly write the numbers down. So make this distinction. The first number is, let's call it X. Second number, let's say is Y. Third number, let's say is Z. So the first property we translate to equation form as what? As this. This is the sum of the numbers, so the square is equals to what? This. This is equation 1. And the second property will translate to this. Equation 2. We have to try to use these two equations to be able to find out what actual values these numbers take. Yeah, they're simultaneous equations, just that they are not linear and it won't be so straightforward solving. So how we are going to do this now is this first equation, if you notice, left-hand side has some terms that occur on the right-hand side. So we expand this left-hand side and see what will be left because some things we cancel out. So when I expand the left-hand side, I'll get this x squared plus y squared plus z squared plus 2 times the pairwise product is equals to this. So as you can see, x squared plus y squared plus z squared is common to both sides. And from here, what do we have? We have that xy plus yz plus zx equals to 0. So we can call this equation 3. So it's now in this equation 3 that it would be a good idea to now use this second equation here. Because this second equation says that xy is equals to z squared. And we can substitute z squared here. We see that each term here will have z in it. So we can now factor out z and see what we get. So from here now, substitute xy for z squared in this equation 3. It is meant to be 3 now. So what do we have? We will have that z squared plus yz plus zx equals 0. So z is common. So this is z plus y plus x equals 0. So what does this mean? It means that z is equals to 0 or x plus y plus z is equals to 0. So as in this case now, we have to, in this question, we have two cases. So when z is 0 or when x plus y plus z is 0. The two cases can actually hold simultaneously, but we have to consider them. So our first case, our case 1, when x plus y plus z is equals to 0. When x plus y plus z is equals to 0, look at this. This is our first equation here now. We can replace it with 0, and what are we going to get? We're going to get 0 is equals to x squared plus y squared plus z squared. So now, remember, if you look at this question now, at first, I didn't notice the terms they used. We're talking of real numbers here. So that is a key observation. So because we're talking of real numbers here, the square of any real number is at least 0. So x squared is at least 0, y squared is at least 0, z squared is at least 0. And if you now add 3 numbers that are at least 0 and their sum is 0, you must have that those 3 numbers, they must be 0, because if either of the 3 is not 0, then their sum will definitely be more than 0. So it means that x squared equals to y squared equals to z squared is equals to 0. And this means that what x equals to y is equals to z is equals to 0. So in this case, when x plus y plus z is equals to 0, and they're combining it together with the first property, you get that all 3 of them are 0. So that is that case. So the next case we're going to do now is somehow similar. So that is case 2, when z is equals to 0. So when z is equals to 0, plug in z equals to 0 here now. Let's apply it here now. What are we going to get? We're going to get that xy is what? 0. And in this first one, if you put x equals 0, what are we going to get? We're going to get that x plus y squared is equals to x squared plus y squared. And so now this first equation now, let's expand it and see what we get. When you expand x plus y squared equals to x squared plus y squared, you actually get x squared plus 2xy plus y squared equals x squared plus y squared. So x squared plus y squared we can subtract from both sides and get that xy is equals to 0 also. So it means that on the condition when z is 0, like both equations become identical. So that will be the implication. And we can also, like, from here imply, like, from this point now, if xy is equals to 0 and z is 0, we can, like, verify that these two equations hold, because both sides here will be 0, and because like expansion, like when you expand something, and you can always go from the factorized form to the expanded form, or from the expanded form to factorized form. So, like, we have been able to show that, like, this condition is actually sufficient. Like, it doesn't necessarily mean that both x and y should be 0. It just means that at least one of them should be 0. Because obviously, like, if product of two numbers is 0, at least one of them should be 0. For example, now if x is 0 and let's say y is 10, like, even if y is not 0, like, these two equations will still hold. You can verify. Let's put 0, 0, 10. So x 0, y 10, get 10 squared is equals to 0 squared plus 10 squared plus 10 squared, 10 squared. Cool. It holds. And this other one's left hand side will be 0, this one will be 0, because at least one of them here is 0. So yeah, we should not, like, only think that the only solution to this is 0, 0, 0. There's also another solution, like when the third number is 0, because remember the question made the distinction. When the third number is 0 and at least the first or second number is 0. So now let's write everything down. So the ordered pair solution, the solutions are what? 0, 0, 0, comma, x 0, 0, comma, y 0, 0, y 0, sorry, 0, y 0, where x and y are arbitrary real numbers. So this is the solution. Remember, as I said, like, this last number has to be 0 because of the way we did it. But this case occurred when x plus y plus z was 0, and this last two here occurred when z was 0. So at least one of x or y should be 0, not necessarily both of them, but both of them can be 0. For example, if we x was 0, we still get this, but it's a repetition. So this is the general solution to this question, and so it was really straightforward. Also, just had to be familiar with identities, like the expansion of all these. Also noticing that if you substitute xy for z squared here, you'll be able to factorize this. So that's another key observation. So those are basically what helped us in this question. The rest was just to break it down to cases, and I'll see you some other times. Thanks for joining us today.